Bismillahirrahmanirrahim. Assalamu alaikum, my dear Falconians of level 8. Today we are going to continue our topic 9.2, that is effects of heat gain and heat loss. Yesterday we discussed about the effect of heat gain and heat loss, and in that topic we discussed that how the gain or loss of heat can change the state of matter and how the change of matter take place during the gain and loss of heat. Now today we are going to continue with this topic, with the same topic, and go in further more details. Like today we are going to discuss that change in volume. We called it expansion and contraction. Now as we all know that there are three states of matter: solid, liquid and gases. So in every state we are going to discuss this property, how the heat loss and heat gain causes the changes in volume. So before starting the topic, all of you take out your books and open page number 194 in front of you while watching this video, so it will become easier for you to understand the topic. The first part on page number 194 in change in volume, expansion and contraction, is thermal expansion and contraction of solids. Now guys, here we are using the word thermal, it expressing the heat. Heat, the expansion and contraction of solids due to the absorption of heat or because of the heat, is called thermal expansion and contraction of solids. So the picture of this iron ball is also drawn in your book on page number 194, in which there are two pictures. First one is before heating and the second one is after heating. And in front of you on the screen, the same picture is present over here, the picture before heating and the picture after heating. Why they are showing these pictures before heating and after heating? They are trying to tell us that solid expands when it gains heat and solid contracts when it loses heat. So basically when the ball was cooled, it easily passed from the ring. But when we heat that ball, the ball of metal will going to expand, and due to the expanding property, it will become bigger in size, and when it will become bigger, so it will unable to pass through that same ring from which it can pass when it is cool or cold, we can say, right? Now different metals expand by different amount for the same temperature change. It's not compulsory that every metal we're going to expand with the same quantity or same size. It depends on the type of metal also. Another picture on page number 195 in front of you, you can see the bimetallic strip that is made up of two different metal strips. Why they are showing this? Because they are trying to tell us or explain us that not every metal going to expand at same temperature, in same condition or in same size, right? So there is a bimetallic strip is made up of two different metal strips welded or riveted together, joined together, we can say in easy words. At room temperature, the bimetallic strip is totally flat because metal is right now in its normal condition. But when you are going to heat that metal or cool that metal, both of the strips bend due to the uneven expansion of two metal strips. Now you can see the difference between the expansion and contraction of both of the metals is totally prominent over here. How it is prominent? That the metal strip is start bending towards the golden line rather than the silver line when it is cold, while it bend towards the silver or grayish line rather than the golden line when it is hot. So it is telling us that the metal which is grayish in color, that is iron, is expanding more at the higher temperature, or we can say no, the golden line, the brass is going to expand more at the high temperature or by absorbing the heat rather than the iron. That's why the strip bends towards the iron, while strip bends towards the brass when it is cold, because brass is going to contract more quickly than the iron. So this is what they are trying to tell us basically, that at the same temperature the expansion and contraction rate of iron and brass is totally different, and this is why the bimetallic strip bends towards when heated and downwards when heated, and it bends upwards when it's going to cool down. Now there is another slide in front of you in which you may understand more easily what is actually happening when solids are absorbing heat. There is a diagrammatic structure of arrangement with the help of arrangement of atoms. These balls are considered as the atoms which are present inside the solid, and when you see that, as we all know that when we talk about the solids, we assume that all the particles or all the atoms of solids are tightly packed with each other, right? But when they start absorbing heat, a little bit distance start appearing between them. They start moving away from each other while they are absorbing heat. So the expansion of solids, as the temperature increases, the atoms basically vibrates more vigorously, means they start vibrating. As we all know that every time atoms of every state of matter is in continuous motion, but when they start absorbing heat, they start moving more vigorously or more speedily, and this more speed or more vigorous movement start pushing them from each other, and that's why when they start pushing them from each other, the volume of the solid start increasing. This is how the change occur in the solid when it going to absorb the heat. That's why we call that solid is going to expand when it going to absorb the heat, and it will release the heat, it will going to contract again, same as the cold diagram of the solid and the hot diagram of the solid. Now let's move towards the next slide, in which we are going to discuss about thermal expansion and contraction of liquids. It is on page number 195. You can see, here you can see the picture in front of you on the screen, where the liquid particles, as we all know that the liquid particles are not tightly packed with each other. They are already little bit far away from each other, little bit, not very much, but a little bit. That's why liquid is can easily flow from one place to another, because the particles are not tightly packed with each other. That's why liquid does not carry any particular shape. So when it start absorbing heat, what will happen? It will start expanding. So when the liquid is heated, the molecules have more energy and they start moving more vigorously, and the movement of the molecules overcome the forces of attraction between the molecules, so allowing them to move freely, and thus the volume of the liquid start increasing again. Now here you can see the picture in front of you, and almost same kind of picture is also drawn on page number 196 in your book. Here we are explaining this property of expansion and contraction of liquid with the help of mercury. As we all know that we saw mercury is the only metal which exists in the form of a liquid, right? So whenever we see in the thermometer, when it absorbs heat or the temperature rises, the level of the mercury start increasing, and when the temperature decreases, level of the mercury start decreasing. So what mercury is? It is a liquid, or it is showing the same property, that it expanding when it gains the heat and it contracting when it loses the heat. Here you can see the picture in your book as well as on your screen, that flask of colored water is placed in hot water. They are calling it a flask of colored water. Well, we are using thermometer with the mercury, and when we put the thermometer in the cold water, the position of the mercury remains same. When we start heating that water, the temperature of the mercury start rising, or we can say the mercury start expanding. But one thing which is different over here, that the property of water. Uh, it's a science tidbit also given in your book as well on page number 196, that water is showing a little bit different property from all other liquids. Asha, you can take the example at your home also. Okay, if you are going to put the water in a container and we are going to put that container in freezer, after some time when we are going to take back that container out from the freezer, we see that the level of the ice which is become the water which has become ice, the level is a little bit increased. And this is what the property of water. Okay, when it cools, it expands, and when it absorbs heat, it contracts. It's water is performing little bit opposite to the other liquids, but for a certain particular temperature, not at every temperature. Like the temperature between the 0 degrees Celsius and 4 degrees Celsius, uh, water shows a different property, while at the other temperature it shows the same property. So it's a little science tidbit regarding liquids and water. Means water is acting a little bit different from the liquids. Now, on the next slide, we can see that thermal expansion and contraction of gases. As we all know that gases are already, the molecules of the gases are already far from each other, while when we start giving heat to them, they start moving more speedily or more vigorously from each other. So the expansion of gases, when the gas is heated, the molecules gain more energy and move faster and further apart. This causes the volume to increase, and when the contraction of gases take place, so at a low temperature the molecule have move slower and have less energy, and that's why they become closer to each other and the volume start decreasing. You can see the picture in front of you on page number 197 also. Here expansion and contraction of gas is shown. When the water, the first of all, when in the cold form, when there is no burner on around the picture, the water was present in the upper bottle as well. Like when we start giving heat, the air start expanding and the water came down in the lower jar more quickly. Now here you can see another example in front of your screen, on your screen. Here we have two empty bottles which are obviously filled with the normal air, and when we are going to heat them in a water bath, in the and we are going to place a balloon on the mouth of the bottle to observe that what actually is happening with the when we are going to give the heat to this bottle. Well, when the bottle is in colder temperature, the balloon is in normal condition and the air which is present inside the bottle, the molecules are in their original form, how they are far away from each other. But when we start heating, you can see that the balloon start blowing, and why it is happening? Because the molecules of the air start expanding, because they are absorbing heat and they start moving more quickly and more vigorously or more fastly, and they start moving. So that's why they need to space to move out. So if the mouth of the bottle is covered with a balloon, so they start entering in the balloon and the balloon start blowing. This is how we can observe that when we provide heat to the gas, they start expanding. So the property, all of the states of matter is showing when we are observing that change in volume is same, that when they absorb the heat, they used to expand. when they they release the heat, they use to contract, right? Now, after watching this video and going through your book, from page number 194 to 197, you will be able to answer this question very easily, that why is it dangerous to heat a completely sealed container of a liquid or gas? If you are going to put the completely sealed container of liquid or a gas on stove and we start providing heat to them, so what will happen to them? Why it is called dangerous? As we already discussed the property of all the states of matter, okay, what will they show, or how they will going to behave when they absorb the heat or when they release the heat, or when they gain the heat or lose the heat. So what will happen to them? So with the help of that whole explanation of this topic, you will be easily able to answer this question. Still you find